So the agenda is going to be what are the context is how do we compare, what are the baselines. Yesterday we talked about foundations and try to define high level requirements for the shared foundation. Then we're going to go into repair logic. It's like a proposal of how do we address that, and then repair topology. So there's a lot that we're going to cover. So a lot of this might be just breezing through very quickly and then go into interaction. So yesterday talked about there's a foundation. What do you need to be credible? And then what are going to be differentiators? This falls in the foundation category. So foundation has a bunch of things I listed yesterday. Those are more technical definitions we can review that later. But the purpose of this one is durability, what the competitive set already has that customers are evaluating, they care about. And here we're landing on, as a starting requirement, we're going to target for 669s. So, yes, sure. And repair, yeah. No, it's durability and repair costs, replica. All of those things are like factors that go into it. So I'm like giving the context. But the target, if we had to say, okay, what is it that we try to get that customers will be aware of, will be their 6.9s. Now, those other things are going to be factors. How did I set that target? When I ask customers, what are you satisfied with? And they're like, oh, it's 6.9s is fine. So that's how I set it. The second one was looking at the potential costs, and we have a 1x overhead as we per yeah. Yeah, there are two of them. One, I talked to customers. Hey, do you need like 11.9s? Yeah, no, we're saying we have it. This is our target. This is our target. This is a target. We're trying to say what's a baseline requirement to ship. Is that clear?
This is the goal for our chain. All needs to get tuned so that we can sell it.
Yeah, we need something. It says, yeah, I put target there. Like, so our target goal is, can we get 6.9s? Like, I need to put some kind of requirement for us to go through the design. But if the question is why is it lower than the competitors, that's a separate thing. But
that was my question. Tim just asked my question.
Yeah. So I talked to customers. It'd be great if we could compete on all of them. Right now, I just want something that we can deliver and that customers are like, this is good for me. Is that good?
All the way to under 3 minutes a year of any interruption. There's a lot that's going to go into that. Are there segments we can get to before we feel like we're at I've signed a contract saying that? Or is it, okay, we're actually building to 30 minutes of downtime in 5.9s, and we will potentially breach the SLA, but we'll claim that we're at that, and we'll pay some people when we're at 30 minutes of downtime, 3 minutes. But trying to frame everything around let's engineer to 3 minutes, that's a lot of engineering to get that final 10x.
Yeah.
Let's not get too hung up on that, I guess is my nudge here.
That's totally fair.
And just one more point.
Yeah.
The comparison there, you're taking on face the 11.9s of the other two.
That's right. That's
why all these things.
Asterisks. So, yeah. So, I'm good with lowering it. The way I did was I asked customers, "What's your expectation from us? Hey, this is what we have. What is okay for you?" Like talking with customers who are Web3. If we can want to lower it, I'm good. But that's coming from customers. I've talked to customers. In it, they don't need hyperscalers. They're fine with something lower, and this is where we landed.
Go ahead, Shiki.
Yeah. So one comment and questions. We are listing competitors and expectations, and I think that is in the context of a market or a specific user set.
Yeah.
So for the users that we have actually talked to,
that's right,
and we asked them about the trade-offs between durability and cost.
Yeah.
And so so this is a subset of information that we got from actual customers for a specific market. So there's obviously other competitors. We can list AWS and S3 as a competitor. That's a different market. And so this is just the information that we have about the specific customers that we actually talked to and what they're willing to do. And it's obviously a trade-off between durability and cost. And by the way, it's not availability. So sometimes we get confused about durability and availability.
Right.
we don't want to lose customers' data. That's really
Yeah.
bad.
This is the likelihood of losing customers' data.
Yeah, it's not availability.
And then the metric against that is typically, and this is where the nuance is, you assume the number of nodes has an annual failure rate, and that's how you get to 3 replicas. So people either say, I want 3 replicas, and I'll ask, well, what do you want to achieve? And then sometimes they don't know nines, but they think about it in replicas. So option 1 is we decrease this, and then effectively in a sort of normal full replica model, it's just 2 nodes, or it's 3. So that's why I picked 3 as seeming like that's where customers were landing. And those who did know nines were like, I'm fine with 6. So is the nudge here, you want it lower? And we're fine with that as a target. I picked this as a minimum viable. But if we think we can go lower, then we can land there. For the customer segment that I talked to,
If we want to have a lower tier
Yeah.
of durability, we need to validate that there's a market for it.
that's right. I
So,
haven't found that.
So until we validate there is a market for lower durability than 6 nines,
That's right.
there's no point in building something toward that. That's how I was.
Yeah, I think this needs to be described again, durability versus availability. How this would, I think, have been most useful for this group is this is the approach that, some other decentralized storage services are taking to arrive at different durability outcomes. This is what durability means in practice. Because again, Will, I think you read availability from the durability 6 nines of like 3 minutes of downtime for being able to access your file. This is probability that your file will no longer be on the network and be unretrievable, and we will have lost that user's data. So it's like effectively translating 6 nines for a year on quality. There's X percentage that you use the system, you trust it with your data, and the data is gone, and it cannot be repaired, and that data is corrupted and can't be served ever again. 1 file per million per year. I thank you very much. Is 6 nines. Yeah. So that helps model things. And then also, can you please just explain what the star and the star is? Because you don't have them on this slide of what those mean. But I think they are important that like these Walrus and Shelby numbers are like the hypothetical targets that they are aiming for as well, not actually metrics that are demonstrated by their systems today. And so again, giving us that context helps us reason about how to compare those things.
All right. So the TLDR is on paper. We understand that they have erasure coding, which is sharding across n number of nodes. And then there's some assumptions that they built in about the reliability of those nodes and the uniqueness of those nodes. So we used a high-level model based on what they did and then said, okay, that's their advertised rate. Whether that's true or not, that's what they're justifying on paper. Now, if it's real or not, there might be some other things, so we can fuzzy around with that. But these are things that on paper, if all those things were true in terms of the number of nodes, that must go down to which they no longer, so in this case, they have a 3f-1, then they will be able to achieve that durability. But if the number of nodes that they have aren't achieved by what they've described, then clearly they lose that. So there's more details in that, but there's this fuzziness in these assumptions that we had to kind of like look at and say, well, it's somewhat credible, but there's these assumptions if they have those number of nodes, and it seems like they do. So that's kind of how we're positioned. So I put that as a take it with grain of salt, but don't dismiss it. Like there is some credibility behind these assumptions, but they're not an exact science. Is that enough? I wouldn't go too deep into that, but
I guess, Molly, the TLDR there is that these 11 nines is the target that everyone uses because it's the one that is common in the centralized solution, but no decentralized can prove that they kind of designed it in that direction from maybe the theory, but in practice no one has it today. So going lower is fine.
Yeah.
And how much lower is have to discuss. We propose, team propose teams because of research on the market. Happy to have feedback. And I think, okay, yeah.
Just be careful because there are many assumptions here.
Yeah.
One is like if you rely on the protocol, like making all the choices on redundancy, then sure, it makes sense to have this discussion. But in the context of Filecoin, you're assuming that the file system will have some redundancy, and like ultimately, let's just be careful to keep that in mind.
We are going to discuss proposal for
that's
the
the
protocol
goal.
later on. Yeah. And
Yeah. But you're right. There are a lot of nuances around how do we get that? How do we have assumptions? There's assumptions about what they do and how they mitigate that. We are making some assumptions. Why some of the SPs are invited to this. Like I did a lot of work. Paul did some great work. How do we actually evaluate what those is at the file system level? And there are things. Okay. And then costs. Okay, great. So what is involved in going through a repair? So I'm just kind of I wanted to breeze through this. There's a lot of things that go into the repair, but
can I stop you for a second?
Yes.
Just to recap, because there was a lot of already discussion, which is great. Let's keep doing it. But just to, so the former slide was a bunch of definitions that I want you to keep in mind, because there is durability, there is repair, there is availability, there is many things. This talk is going to be about durability. So the probability that your file is not lost in the system. And when you speak about durability, you have to speak about repair, because durability is achieved always with the redundancy with multiple replicas. And of course, if you start from an optimal place with, I don't know, 3, 4, 6 replicas, and one goes down, if you want to maintain the same level of the durability, you have to repair. Okay, so that's why we focus on durability, means at the protocol level, focus on the repair.
right. Thank you. And so the context is, okay, what does it mean to repair? We're going to just use that as a shorthand, but there's a bunch of things that are involved. I could be missing things, but in a general flow, what does it mean? That node has gone down. The broad things are, I need to detect, I need to get the source, I need to pull it back, I need to complete the recovery, and then any kind of, for us, payment and routing. So I'm gonna move on unless there are questions, because I want to get to the lots of things happen. That's like the takeaway for this slide. Okay. No. Okay. Okay. Yes, there's a lot. So I'll walk through quickly. So in order, I have to know that something has gone down. The data is lost or the node is down. And then there's some assumption on how frequently if I do it. If I do it once a year, it's sort of like, and I effectively have no repair. Then I have to say, okay, who has the right source? And so it depends also on, is it sharded versus not? In our case, we just have to say somebody has the data that was missing. Who's going to now have that? Who's going to be the instantiate node? That's the recovery target. Now I've got to actually perform the repair, which is I take that data, I put it on the thing, make sure that it's working. Then there's a route, meaning, okay, now I, the client, want the data. I was originally assuming it's going to be on this node. That node is gone. How do I know what's the right nodes to use? And then there's some payment that has to happen. There's some cost associated with that movement. So those are the big buckets of things. I'm sure there are more details, but I wanted to keep it high.
Yeah, sorry, maybe I'm a party pooper, but
Yeah, fine.
so why even do this on the protocol level? Like, I mean, like ultimately the customer, what they care is durability, and like you can prove that the durability through window post. Like you can say like, oh, this thing has been around for 3 years. Window post has worked successfully every single day. So this implies that there is a particular durability, which can be like even 11 nines based on like past performance. So in that particular case, like we are fulfilling the needs of the customer, right? Because like practically what's happening, all of this is already happening on a layer beneath, which is basically the storage layer, where you have like these big JBots full of drives, and you can have 5 drives fail, and like people actually go physically there, replace drives. That's expected, and like the same exact thing happens on that layer, which is not accounted for in this particular context. So like we're basically adding another layer of redundancy, which is basically just on a like separate layer, but like redundancy is already there.
So I think where this is coming from is also an important thing to talk about, of like, why are we having this conversation about durability repair? This is all happening at the Filecoin on-chain cloud layer, which is a layer of smart contracts offering PDP warm storage services right now. In the future, we also want it to not just have PDP, but have other service layers. But when folks are showing up to the Filecoin warm storage service, which is a smart contract, and making deals with a Filecoin storage provider, it can and totally might happen that PDP provider, leaves the network over some period of time. The deals that you are making through Filecoin Pay with the warm storage service are like, as you go sort of deals. You're not committing to a 5-year window upfront with a lot of collateral associated with it, at least not right now. You can do that, but that's not the default. And so when we're talking about wanting to have there be a repair market, right now, the way that you do that in the PoRep process in Filecoin F05 land is the client makes a deal for a specific window of time with a storage provider. There is pretty good durability of that storage provider offering or like being able to prove that they have the sealed replica of the data. Relatively, right now they can fail those checks once every 14 days or 10 days or something like that. And a number of them do, but they're able to recover and keep going. Those storage providers can terminate or fail out. If they do, the client, that deal will fault and the data will not be there anymore, but it's on the client to do any sort of replication strategy on their end and track whether or not their deals are still active on their end. There isn't any tooling for them in the network. There's not a repair market. In the early design of Filecoin, we talked about wanting the network to be able to monitor repair and replicate to different storage providers automatically if a deal went down before the kind of deal window had expired. And what we're trying to do here is start building on-chain like repair and durability systems so that especially when you're operating in a warm storage environment, that you can then automatically fail over between storage providers and perform a replication model that gives you a good level of durability. We'll talk about like using PoRep as one strategy within it, but anyways, like we are specifically talking about innovating in a new area we've talked about for a long time that we think will add benefits to the end user. Because what we're hearing from the end user is like, I don't want to manage my own replication strategy. I don't want to have to manage my own like failure alerts. I want the Filecoin system to do that for me.
And then the second one is like, that was good context. And I did talk to a bunch of people who are close to the SPs around the assumption for a single PoRep provider. What is their durability? And it is actually a wider range than saying they're all 11.9s. So I think that's the thing that we'll have as a discussion. So,
And like to the core is like this conversation is like moving right now. The SP relationship is between the client and the end SPs. And what we learned from the customer is like they want the relationship to be more with the client and the Filecoin network. And we cannot just like bet on all the SPs can be like Ramo or like Aurora that has best practice or whatever. And we don't want the everything is like bound by legal contracts between each single client, which each single SPs in the network. That's why they're like at the Filecoin level, there's got to be like some protocols, some mechanisms that provides higher guarantees durabilities even on like permissionless like choppy SPs to give that to the users.
All of this makes sense in the context of untrusted providers, and like that was my main thing that was missing here.
And may I add that we are not excluding the fact that there is some risk management done at the SP level that we don't see.
yeah.
Like the dead is just that we want also some on-chain understanding of how the chain can do risk management, having different SP or copies.
But also variability in how PoRep is done. Okay, so if the logic, so this is one of the things we could get through quickly, but maybe it won't be. So we've identified there's already client side activity work. We already know the service delivery that's already been done. That's how we're operating live now, right? That's a warm service contract. And then we're saying, where does this repair logic live? So we want to kind of like align from the perspective of, hey, just a principle of separation of concerns. Where should this go? Should we push it all on the client side? Should we make this big service contract big? Or should we propose a separation of concerns, repair logic, the client side, it remains this SDK, and then this service. So yes. So number one is just client side. Number two, it's you put it all in the service contract. Number three, client SDK, the MSP is a separation of concern, and then the service contract. So 1, 2, and 3 correlates to this. Good? Okay. go through? So go through it. So client side, all of that logic for how do I detect that whole list of things for the repair that lives on the client side. The service side, which exists as a service contract gets updated, it does all those things. The third one is we have a separation of concerns, and that is moved into another service, which then orchestrates those things. So we now have three things for three sort of like distinct-ish parts. Yeah, these are three different. Yeah. So option 1, option 2, option 3. And so how do we evaluate where things are and want to gain alignment and agreement on what those proposals are? These were the considerations we took. One has more client software complexity. We evaluate what's the implicit trust levels that might be affected by having this other entity. And then for me, like, hey, do I care? What's the cost to the customer? And then any impact on our end goal, which is durability guarantees.
So I think it's worth to maybe repeat that the MSP is a new entity that we introduced. So right now in FOC, we have the client side, we have the service, and SP, the service, the contract and SP, right? So there's these three parties. The option 1 here is that everything is on the client. Option 2, everything is on this already existing service contract. And then option 3 is the one that requires to introduce a new entity. So we are going to have to really create a smart contract and the off-chain software to create this new kind of router. I would call it router, that we call it the manager SP, that is going to contain all the logic that was shown in a slide before about the repair. So how do you detect off-chain? Probably it's like some explorer to detect that a replica went down, then who to contact to actually get the data back and create a new replica. How do you update the retrieval routing and so on? That's completely new.
Wouldn't it be something similar? I'm just trying to understand what's different between 2 and.
The logic that you have to implement is similar, and even the tools is similar. It's where they live. It's where they live. It's like the smart contract is like another method in the service contract, or it's a completely different service smart contract that is run
Okay, thank you.
as an independent module.
I think a key differentiator between the option, thank you, sorry. Key differentiator between option 2 and option 3 was if you put it into a canonical service contract, there's maybe like actually 2 different options within there. Option A is you bake it into the warm storage service itself. And you're like, all right, this is the repair and replication logic for the warm storage service. It's now going to handle its like replication and repair policy. Option 2 would be it's a different, fully autonomous smart contract living in the network that is trying to use, entirely on-chain calls, may or may not require an Oracle publishing some data onto the network, trying to execute that, which could then be reused by other service contracts, but would encapsulate one specific set of repair logic, and it would not be like we would all have to be like, yep, that is the repair logic that is going to be like, and it's a smart contract update to change that repair or replication logic, and it's canonical and is hard coded into the contract itself. The MSP option gives you a layer of modularity, indirection, where you can have multiple different MSP operators, which are then implementing different types of repair logic. You can still have an MSP that is the entirely smart contract service side. However, you could have N MSPs that are all operating as aggregator layers on top of a specific repair and replication logic with a set of underlying service providers that they are monitoring and replicating across. But you could have many different strategies and many different kind of like providers of those strategies that you then multiplex within. And at the end of the day, this MSP structure is offering the same interface as a storage provider. And so they are abstracting that complexity away from the service contract itself, the warm storage service, so that the warm storage service can operate with that MSP alongside other SPs, kind of, without having to encode all of that complexity into the service logic itself. That make sense?
Yeah, I would maybe caveat with any MSP model to be very, very, very careful about the internet bandwidth. Like even if you have 10 gigabit pipe to the internet, you can only really move 100 terabytes per day, which means, if you want to reach some durability, it has two factors. There's the annual failure rate. It has the time to repair. So if you only can move 100 terabytes per day, you can only repair 100 terabytes per day. And assuming any bandwidth above that is pretty optimistic, then, like also what you are likely to repair in this market is not a single failing disk, because those providers are incentivized to repair themselves. You're more likely to repair entire providers. So if you have multi-petabyte providers, you need to be very, very careful about bandwidth.
A quick answer. Yes, but that's why actually we like this proposal more, because in this way, the MSP, you don't have to think there is one MSP for the entire network. MSP now is a service. It's a service itself, it's the repair service. And hopefully, we are going to see many repair services, and they are going to be able to handle large data or large SPs going down, because they have to handle like one SP each, something like that. So there is a localization in the network with many MSPs working for the network.
Yeah, but
I think that's like very confusing. Like now you're saying MSP is like a service. I think like what you meant here is like, in this case, we totally agree with you. MSP are not the one like running infrastructure, whatever. You can just be software that detecting, manage a bunch of these SPs, right? Like it's like an entity, a new role that's like collecting data centers and SPs, and to make sure that the collective of these like data centers or SP node can deliver certain level of the durability guarantees like they need. So like I think before talking about what's living on the contract or whatever, I think to answer a big sorry, I'm going back to your question, is like, where does the responsibility lies? Today, Redmile is on the service market side, right? Like think about on-ramps today. On-ramps today, they are the one managing all the service guarantees. It's like they need to make sure they build the infrastructure to guarantee like durability and like so on and so forth. Instead, what we're trying to say is like, let the people who know about the service, like running the service, to take that responsibility, so that we have MSPs who work with a bunch of the data centers and so on and so forth to provide those guarantees. And then the services can just be working with the MSPs to get the service they need to provide to their customer. I think that's the main layer we're talking about, if that makes sense.
I think the core thing that you're describing here is like, hey, there's a set of concerns that need to be handled a layer above the SPs. You need a different abstraction set. You need to draw the boundaries at a different layer. And I think that makes a ton of sense. However, what I'm not seeing you working through is, how does this work in normal large-scale centralized storage networks, to understand what are the abstraction structures that exist and why, meaning those abstractions went through a 20-year optimization process and exist for very good reasons. Usually those abstractions don't just randomly happen. They have serious optimization pressures, and they develop into market-wide structures that then shape the nature of software and human organizations and hardware. And so if you don't map onto those abstractions that already exist, you're likely gonna just not meet the market where the market needs to be met, and like it's not gonna work. And so you have to do a strong review of like how these layers of concerns already happen in large-scale centralized storage networks. And then for our side, figure out the range of concerns, all the way from like the physical storage all the way to like the end user and all of the layering. You have to think of like all the different structures and layers and what concerns exist. And then once you do a good mapping between these, then you can draw good abstractions that are likely to work. And I'm not seeing that here. I'm seeing you sort of like realize you need a new abstraction and like you're sort of creating it and describing it. But what's very likely to happen if you don't do that other work that I'm describing is that you'll create something that just doesn't fit the set of concerns and is not going to work later on. So I think you need to like push for doing that work that I just described.
Okay, I agree. These were abstractions of what the centralized providers do, but I didn't go into the technical design because it was just an explanation. But I think that's fair to say this is the methodology which we used. We also have a version of it from what the decentralized providers, because they kind of are a comparison set of like what is the nature of their detection and recovery, and we can talk about those in the design phase. Is that good? Yeah, great. Awesome. Thank you. Is there someone else who had a question? Okay. So these were considerations that we said, okay, how do we evaluate? We're trying to address client-side complexity. It's very high if you put it in the client side as option 1. Service-side complexity gets super high if it's all just put into the existing service. Trust levels, maybe there's some decreased level of trust, but we just kind of wanted to open up in terms of if you had to make a call, who would want to put it all on client side? Just say, give it to them. Who would say, just put it into the existing storage service? Then who would want to say, I want a separation of concerns? And then we'll go into the detailed implementation. But right now the goal is I want a separation of concerns.
Yeah, I think Signups SDK would be a good fit for email repairability and stuff like that. So that's client side.
Client side. Okay. Can you share a little bit why that whole set of logic would need to live on the client side, and then how much automation would be done? Like, I just want to hear kind of like
Yeah, I think like things like erasure coding could be done on the client side, and yeah, just I think picking SPs and just doing the replicas, so multiple deals, etc. So I think that wouldn't be I think it's possible. It's maybe way faster to do that than having this new persona MSP that you mentioned. So I think that could kind of increase the complexity. I think putting things on client side, especially in the SDK, could be a good idea, especially for the builders as well. So builders could do a different kind of products with it.
By the way, what you just described is literally how Walrus works. Like literally this.
Yeah, I've been playing around with Walrus, so yeah. They're kind of inspiration here, but I think also the detection is done on protocol level, so it's not exactly the same, but yeah, at least the erasure encoding and stuff like that.
So you would push the job of delivering bytes in multiple places to the client side?
Yeah, that's what Walrus does.
And also a good idea, right?
Is it well, there's a choice spectrum here in complexity. Where does the complexity live? And in a Web3 world, we have the choice of pushing all the complexity to the client side, but then the client has to maintain a lot of state, and the client is the place where you have to do the reassembly of those things. So if you want to do things like distribute your content to others, and you've got erasure coding, you're going to be distributing a lot of information to other parties to do the reassembly. We can do that, but this is all about the choice of where are we willing to put the complexity. And as we are going through the journey of developing an SDK for customers for FOC, we're actually starting to discover that putting more complexity in the SDK may not be ideal, because we're actually lumping developers with things that we are even having difficulty explaining to them, and we're not even at erasure coding. So this is all about where are we willing to put the complexity? What costs are we willing to make the developer and the client bear? And how could we maybe trade those things off to make a more usable, more consumable service?
Okay, hint. So Angelo, then Sergio, then Volk.
I can go first. Okay.
From a client perspective, I think I'm all the rest of the people here. Like on the Akave side, we do the same thing, like erasure coding, all the intelligence is in the SDK from a client side perspective. Main reason why we want to do that is because of the integration with blockchain. We want to keep all the privacy and the security and the intelligence on the client side. Decisions made are there. They own everything. They kind of manage it that way. So makes it very logical from that perspective.
Yeah. Also, I think whether the erasure coding lives on the client side doesn't make much of this difference
But
because
can we try to abstract away? Sorry to interrupt, but can we try to abstract away from using erasure coding and
Okay.
just thinking maybe it's just multiple replicas?
yeah,
Because I want to like
yeah.
a tool to constrain our design
Yeah,
design
thank you.
space.
Yeah, thank you. So either way, the configuration is gonna live on the client side. Clients will have to pick how many replicas or whatever the options they want. Either way, and that is gonna be forwarded to this persona. So either way, the client will make some kind of decisions, what kind of services they want to include, etc., etc. But we are only now talking about where the compute part is gonna live, or whatever, or replication or whatever. So yeah, I think living on client side could be done faster than having this additional persona.
Look,
Maybe I'm confused, but like looks to me that we're talking about the same thing because like no one here is actually thinking about the real clients, like the actual users of the storage. Everyone is referring to them as a client, like using the SDK. So in that context, it seems that like the client SDK and the MSP is the same exact thing, where like there are groups of people that wanna basically manage the interaction and like they wanna have the ability of like somehow like interacting with that, with which I assume they would wanna do through the SDK. But like the MSP, I'm not getting the difference here because like ultimately there are teams, and by the way, like this is also what we've seen with PoRep. Like there are teams that of course understand the protocol, want to interact with the protocol, that there are rules in which they can interact with the protocol, and based on that, uh, they would want to interact somehow with the protocol. My understanding is that like everyone wants to use the SDK for that, but ultimately they are playing the role of the MSP. But like the way they would but like maybe I'm getting something wrong.
I think there's we are conflating a little bit, at least for me, two concepts in the client side, like word. Because one thing is, and I agree with Vuk, because like we can think about the MSP as a client side. Depends what you mean by client side. So one thing is we have a client for the platform that people use on the back end. So they build a product on top, but it's on the back end. They handle everything. Then I agree we can do the sharding, erasure coding, pushing bytes to multiple places, owning everything. But anyone can do that by just like calling directly the contract. They don't strictly need an SDK, right? But when you talked about a client side, is like building a web app. We don't want our web apps to send bytes everywhere, right? Because they need to be slim. So there's two concepts here that we need to be more clear what we're talking about. Because for me, like the MSP can be a client side SDK too, but it's different from.
Yes.
I think it's the user experience, right? And
Right.
if you're saying client side and you give the client, whoever that is, an SDK or a CLI that they can simply upload a file, they don't have to worry about it, but they get the erasure encoding and the default configuration, then that's fine. The replication probably doesn't need to happen there; it needs to happen outside. But if they don't know it's happening, but they can configure it, it's fine.
Like a flag here, if you go back to slide 5, so one slide back from here, when we're talking about the logic of replication and repair, there's multiple different things. We're not just talking about how many copies do I send to different storage providers at the SDK level. We're also talking about detection of errors and response to that. And so if that is happening on the client side, where the client, say the SDK needs to be operating and running in order to do that like recovery and repair and replication of missing erasured copies. That's now an additional overhead in terms of those. You could potentially separate those concerns where you have some initial participation at an SDK level with the network and ecosystem that has created your erasure coded replicas or whatever. But when you get some failure on those set of replicas, some process needs to run somewhere that is going to make additional replicas in order to get you back to the original durability threshold that you're aiming for. And so the question is that living at the SDK level where you need to be running and operating that SDK kind of at all times to monitor and respond to failures to re-achieve your replica baseline? Is that a separate system that is running as a service contract on the network that is monitoring and, operating that repair for you, which means that it will need to get alerts that, a subset of your replicas have gone offline and make new deals on your behalf to initiate new replicas of your service? Or is that some kind of like third-party service that you are hiring that is now monitoring your data and initiating replication? I want us to be clear that it isn't the same thing as like an initial configuration with an SDK. Sure, you can totally have your SDK from a client perspective initiate N replicas. We actually are doing that right now in the Synapse SDK. It does initiate 2 replicas for you. But when we talk about actually doing the effort of like repair over time, that is an active process that's going to require monitoring within the network and initiating new services. And so if we push that into the SDK is going to need to be online for the entire length of the service contract and responding to new alerts from the system. So that's a design constraint. I do think just to like, this might be something where we need to do more deep market research on what the different option spaces are, also looking at how this is architected inside of like Amazon cloud environments, so that we aren't just comparing ourselves to other decentralized networks, but we're looking at the subsystems that exist there.
I would just suggest that we kind of decouple like product versus implementations because it's a bit confusing. SDK for many people means something and like for other means something else. So ultimately there are, I would just leave it there.
Yeah, it's Molly said a lot of what I wanted to say, but I'd like to repackage as a question that I don't think as presented we can answer the questions here because it purely depends what product we're trying to build for what customer, right? And naively, the way I would put that is we have to just make a stand and say, are we building a product where the impression and the offering and all of the feature development goes into this kind of concept that you are storing on FOC? Or are we building something which is a variation of the marketplace? Or are we building something which is a mixture of the two? Because at the moment, one of the great things about FOC is that I just stick stuff on Synapse and it chooses the 2 replicas for me. And I don't know who they are. I don't care who they are. And so that gives me the impression of a builder who's just sticking stuff on a service which is resilient, in which case the SDK is absolutely not the right place to put the repair for all the reasons that Molly said. But we just have to decide, because the conversations we've had here all make sense, but they all define completely different product offerings. You just need to pick one.
After Shashank, I'll just land on what were the first.
So Molly said like most of the things that I wanted to say, replication and repair are like very different things. For repair, you would have to basically run a server that receives a notification and replicates, reaches that threshold. That can't be that is not ideal to be done on client side. One way for doing that could be to have some incentivization mechanism that we put a default in a smart contract level that we need 3 replicas. That is the default that we have. As soon as SP goes down, anyone can go and check that, okay, now there are 2 replicas, and there is incentivization mechanism for anyone to come up and
just put the threshold back to 3 and he gets some rewards. So we can do that on a smart contract level. User would not have to care that he just stores it with 3 replicas. It goes down, he can see that, but everyone is incentivized to again restore it to 3 replicas. That could be a way to go forward. One more thing is like, I don't think we can do all this logic in the core FWSS contract. We would obviously need another contract building on top of that for sure. So it would like, I think the third, like second option doesn't, if it is like just making everything into FWSS, it would not work. Like already it is too big. Yeah.
Do you both wanna?
Yeah, I guess we're running out of time here. So just to land, just the open question was like, who's the persona? And going back to Juan, he's like, a lot of people want to use like hyperscalers and they just upload. They have an SDK or they use a UI, they upload and they store and they take care of it. So that's the builder who's using it. They're building apps and so forth. So it does feel like there's a lot of things that we still want to get to. I would like, if anyone's interested, to have an overflow time for us to land some of these things, just to make sure that we're aligned on a decision. But I think we're running out of time at this point. So, do we have time for that? Okay.
We're just like no, just like finish this one.
Okay.
Go through your topologies, and then we're gonna.
Okay, great. So this is the next one, which really was the one we wanted to spend time on, was the assumptions around what we have in terms of the capabilities and to align. I spent some time talking with SPs and people working with them to land on that. And the reason why is we want to understand what is the durability assumptions that we make with existing PDP. So Molly referenced what that was. They're a PoRep, and I've heard variations on what's the expected durability. One case is a single PoRep provider already has 11 nines. I've heard from others like maybe a single provider is 98%, so it's like 2. So there's some assumptions that we want to like land on because that determines what is the assumptions we make in terms of the topology of the underlying service. Meaning, is it 3 PDPs? Is it 5 PoReps? Is it a mixture of those? And that's kind of where we want to land this discussion because that also determines how do we have the mechanism to ensure the repair and the availability. So is that context clear? And so is it possible for us to like land on consensus on what we think the durability is of PDP? So can I have someone just, no, we don't want to start there? Like, okay. Okay. So the first one is, what is the estimated durability? And so if we go through PDP, that means the likelihood that over a year that it doesn't fault. Not only doesn't fault, but they don't leave. I got an airdrop and I'm going to go someplace else. I know that it's going to be there and I'm going to be able to retrieve my document, my files over a year period and not have a percentage of it gone, right?
Just the point is like, we can't know this right now. I bet you right now it's less than 50%.
Yes.
Or even lower. I mean, less than 50%. But like, you know, the high level point, we have no PDP operators on mainnet that are being monitored for this right now. You can look at the PDP operators on calibration net and look at Dealbot statistics around it. But like, you know, it's very early and it's also very much a design of how you build the PDP service contract and what it's being monitored for. If you have collateral and you have slashing, you will get a higher level of PDP service durability because you will be incentivizing it with the provider. If you don't do that, then you have expressly structured the system so that any PDP provider can walk away at any given point in time. There's no like downside to that for them, and so you will end up with much more churn and turnover. So like it's similar to other systems. Your node assumptions of how much you can expect a node to be around are a function of how much you incentivize and collateralize that assumption. And we don't have any collateral around it right now, so we should expect it to be very low. But we don't have enough data to make any sort of prediction of what that is.
Right. So we separated those without incentives, those where PDP does have slashing. And so I think we don't have exact data, but I think we need to reason about what is a reasonable expectation so that we understand that's not something we want. So I've heard 50% from other parties and maybe even lower. So I just want to land. That does not seem to be awesome unless somebody thinks that's fine because it's offset by other things. Okay. Right. Okay. Sure. Okay. Why don't we just come to this and then we'll do PoRep. So with slashing, we're making some level of assumptions. Now that's
So Mark,
Oh,
quick question.
yes.
Right, sorry, you're in the back here.
Yeah.
50%, is that based on the curated list of SPs that we're working with? Because that seems very, very low.
Yeah. This is right now not based on the curated list. This is like a provider that's operating.
Okay, this is just in the future, like anybody joins and
I think we're talking about the current capability, like our current expectation of a generic PDP service provider. I don't think, I mean, obviously we would set our bar for at the warm storage service level, what level of provider uh, performance would you need to qualify for getting warm storage service deals? But then that would only be a small subset of storage providers. And right now that does live at a management level of managing the provider whitelist in the warm storage service contract. It doesn't live at a smart contract level, and that is a downside, right? It isn't there isn't an automated process for moving providers in and out.
Yeah. I think simply it's just like there's no data or mechanism to measure durability with PDP right now, because right now it's only saying like availability. All the stack that we're building is just availability, and that's why we are even. I think it got derailed, but that's why we are even having this session to say what are the things that we should be doing, adding on either checking or like adding protocol things to make sure that we can actually have durability on top of the PDP service that we're having. So like the number here, I just don't give a fuck about that, because like there's no number, there's no durability at all. We have availability. I just want to be very clear, like just to say that. That's why we are even having this conversation.
No, I think that at least my framing would be
We are not signing a contract with the SPs that we are working with to say, hey, you have to give us this level of durability. So there's zero guarantees of that, and that's a problem we need to solve. We don't have it, and we need to admit it, and we need to bring it.
Sorry, just for context though, you can't have availability without the data. So your availability when you talk. But your availability is always going to be equal or lower to your durability, because you can't make data available that you do not have. Does that? No, you disagree? Like the meta point I'm making when we talk about availability of data and serving that data, like I understand that they are different things. I agree, but my meta point is if you are going to make the PDP proofs to make and correctly respond to a PDP proof, the data must exist somewhere.
Exactly, somewhere.
It doesn't need, yeah.
It's not durable in the sense of that you are the entity that produced the proof is in any way contributing to the to the increase of the durability of this data. All they did is they access the data somehow. It's very viable for a PDP miner today to basically go to certain entities that like to pay for open data access, sign up for PDP, and then get all the proofs satisfied by going back to the S3 open access bucket and just do them from there without ever having any data locally. So, and I think this is what Jenny is kind of alluding to as well, that durability and accessibility are completely different things.
Yeah, but at the end of the day, if you're putting a bounty on accessibility, you need to have at least one copy of the data to serve your accessibility proof. So in terms of a baseline on your data existence, which is a subset of durability, like there's at least one copy of the data somewhere in order to respond to an accessibility proof of the data. And again, I just think that that's an important component. In this world, we're not talking about any incentives for doing it. So there is no incentive to for example, have public access data that you flow through PDP such that you can re-access it from a public data perspective, unless you want the proof component of it or something like that.
I just want to go back to what Tim was like when it started, right? Like what durability we're talking about is like if that one copy of data, that node is down, how fast can we get another copy up? Like that's the durability that we're talking about. And that right now, that mechanism doesn't exist, and we need to make that happen. That's why we need repair and like, when a copy is down, how can you get another copy up? That's increasing the overall durability of the protocol. Is that right?
Wait again. First question.
And the likelihood of losing the data in the first place. I just want to land that. So PoRep, I just want to put a number so that we can work with a shared assumption. Like there's some that sound like any one node has like 11 nines, like Luke said. There's some that have said it's like maybe call it 98, 99, just for the purposes so that we can model this out. And any opposition to us is saying it's 99%. Like we get 99% on
Book. Like for PoRep, are you fine saying that the one PoRep replica gives you 2 nines? Two nines?
So I think the issue is just what Maciek said, which is maybe on average across the entire population it's 99%, but the problem is it will be 10 pips at once, and that's your issue.
Yeah, but the redundancy is that because how PoRep with the slashing of blah 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 works. Outside, give me the number from outside. I don't want to know what you PoRep provider does.
I would need to check the numbers because
But you're wrong.
Lucas is better at these things. But we're offering 12 nines. We're signing contracts on 12 nines. But I think it involves a couple of replicas.
So just as context, and then Ian, like that number is not just the hard drive, it's also the power, it's also their data center, it's also force majeure. It's like the things that I looked at about how they did, they showed that actually everything eventually correlates. So it gets harder and harder to deal with the software. If the same software, it all goes down. It's like all those things.
You need to definitely have different data centers.
Yeah.
In different regions.
Yeah. Ian.
So I think a single SP who's really responsible can definitely reach multiple nines of availability. I would probably not put more than 1 9 there, only because I think the risk of an SP going out of business and terminating all of their sectors and deciding to leave the ecosystem is the most existential risk that would cause that data to not be durable right now.
Yes.
And I think that we need to basically just account for that.
Yeah.
If the SP wants to stay in business, I totally trust that they're going to have multiple erasure encoded copies in multiple regions. Like that's part of their business.
Yeah. Anybody landing there?
Just in addition, an event that makes one SP leave the ecosystem is like an event that makes multiple SPs leave the ecosystem. So we have an event that,
Okay. So I have heard those similar concerns, trying to like land on a number that we can just move forward with. Can we go to 90%? And just call it that so that we have the repair that takes that in mind. We have some constraint to work with, or do we need to open the aperture still?
I think, I really need to disagree with these statements because look like sure, like many providers are not selling for storage. But like you can look it from the perspective of, okay, like folks are depending exclusively on block rewards. And then sure, like risk is through the roof. But like you can also look it from the perspective of like all of the providers providing storage on the Filecoin network are way more profitable than the ones that are not on the Filecoin network. And in that context, like the risk goes down because you have like a different revenue stream coming from the block rewards.
Okay.
So I wouldn't say that the fact that like providers are on the Filecoin network is a source of risk. Like I would say the risk goes down in that particular case. So that it's definitely more than like a couple of nines.
Can we, since we're way over time for this session, can you just go understand you need to, but I would recommend you get this information from the network by doing a data analysis of here are all the PoReps, here are how many, like what the fault rate is. Here is how many have terminated to date before the end of their deal term. From that, I can assess what is in practice the actual fault rate of deals before their client like deal term ended, and I can get our current PoRep like durability metric, because if you are continuing to respond to your PoRep proofs, then you have the data durability to do so. If you terminate before the end of your deal term, then that is a deal that wasn't fully met over the window of your data expectation, and so you can get it from that direction. But just can you just walk us through the last 3 slides and then we can end?
Okay, great. So if we want to do that, there's a bunch of configurations. Some of you know what does it mean for us to configure it based on those constraints of what are the performance guarantees that we have from the individual pieces. Is it PDP only with some slashing? Is it a combination of PDP and PoRep? Is there some other design elements that we've like proposed? And so I think this is where perhaps the overflow is going to be. Like, if we assume that we've got this thing, and then we understand, okay, there's some expectation, it's very low on PDP, something increases when it goes to slashing, there's some number that we're going to land on. We looked at the faults numbers, and like, are we comfortable using that? So we can use that. What is the configuration that we have such that we can engage in repair and durability? So these were some of the topologies. This is where we want to workshop with folks. So for example, if we use the MSP, maybe there are providers that are just both PDP and PoRep. Or we had a conversation with someone who was like, well, maybe we find some ways where PDP, we find some uniqueness and some slashing. We have those, and we have a guarantee, a very high expectation on that never going away with PoRep. So back to those assumptions. Another one is we actually have the PoReps are the ones that really have it, and we actually model a way such that we know that there's durability from those, and they're economically incentivized to make sure that there's a live PDP so that the customer can always retrieve their thing. And if that goes down, there's some incentive to like repair that and restore that. So those are 3 examples of the way to work through it. We're not going to be able to solve it right now in 4 minutes, but I would like anybody who's interested to find us, and then let's schedule time. We have overflow. Worst case, tomorrow there's an overflow section where if we have enough people, I would really love to like grab that, or time that if that doesn't work, we'll find time. But that's my proposal. Let's have the overflow time for those who are interested. This is very important for us to land.